Hey, I'm Dave. Welcome to my shop. I'm Dave Plummer, a retired operating systems engineer going back to the MS-DOS and Windows 95 days. And today, it's time for round 2 in the epic software drag racing series, where we're pitting 45 brave computer languages against one another in a sudden death, no-holds-barred showdown of prime number generating fury. You'll get desensitized to the carnage soon enough, but until then, I must warn you to brace yourself for some of the most computationally intense YouTube footage that you've ever seen. All today in Dave's Garage. Our first order of business today will be to deal with a hot topic that has come up again and again in the video comments, and after that, we'll be getting deeper into the results today as we keep on adding new languages to the competition results. We'll drop into the code editor and I'll take you on a guided tour of a few languages that everybody has probably heard of today, where you'll learn cool new keywords like unless and bless and last. Still, even if none of the languages I feature today becomes one of your favorites, that's okay. Because remember, the whole point of this series is to go through the quick review of languages that you don't use daily to get you a sense of the language flavor, how it works, and as I like to say, just enough knowledge to be dangerous. If you just stumbled across this video without seeing round 1 of the competition, fear not, as these language episodes can be watched out of order. So you can and absolutely should go back and watch the others later. For now, grab yourself a venti chai and have your assistant hold your calls for a little while because we've got a lot to cover. Once we're done the language review, we'll take the new contenders to the track and run them heads up for a side-by-side performance showdown. Just like a lane at a real drag strip, each language will be given a dedicated CPU core and the task of solving for all the prime numbers under 1 million, as many times per second as possible. The language with the most passes per second becomes today's winner, and at the end of the competition, the highest performing language at that time will be crowned the overall winner. Right now, the crown is being tossed back and forth between Zig, Rust, Nim, and C#, which really surprised me. In fact, it surprised me so much that right now would be a good time to get a vidcap of my surprised face for the video thumbnail. If you absolutely, positively can't wait and want to get right into the code, you can jump ahead to about 9:10.
Len, don't do it!
If you do that, however, you would miss the latest gossip, rules, rants, and my philosophizing on assembly language, all up next. And be sure to subscribe to the channel so you get notified of future episodes in the series, which I will be releasing on a regular basis. After all, if you don't sub, you just might miss your favorite language. The fastest computer language series has really taken off, even to the extent that the Primes project was suddenly the #2 trending project on Github this week. A huge thanks goes out to everybody involved in that end of things, both as administrators, contributors, and even just folks interested in seeing how it all works. Be sure to check out the video description for a link to the GitHub repo where you can just lurk and check out the code in 45 completely different languages. Go have a browse and see what some of the weirder languages look like at your own speed. And don't worry, you can't break anything by looking, but you can cruise around every solution in all of its syntax highlighted glory right from the comfort of your web browser. Join the discussions and ask your questions. If you like what you see, please give the project a star on GitHub and tell a friend to check it out as well. And just when I think I've seen it all, someone will come along and add a new language or a new platform. A few minutes ago, in fact, I saw a pull request for what looks like an IBM 360 mainframe version, so by all means, if you know your way around a language that we don't have, like Snowball or Prolog or many others, please dive on in. The more languages we stick on my newfangled Rosetta Stone, the better. And it's a great place to preserve some of the oldest ones. I mean, what if you are the only person left on Earth who knows how to write a prime sieve in job control language? Don't you have a moral obligation to the children? Or at least to the child programmers? And just what was that hot topic in the comments that I was referring to? Since that first episode aired, a number of people in the emails and comments and so on that I receive, as well as online in the comments, have flatly stated that, of course, assembly is by definition the fastest language. One person even went so far as to state that because it was a well-known fact that C and assembly are the fastest languages, this whole thing was just pointless and does not even need to exist as a concept. Sort of nihilist in a no country for old programmers kind of way, if you know what I mean. Do I? Do I even know what I mean? Either way, this question has stimulated some very healthy debate in the comments section of round 1, so it's something I did want to address. Since all languages ultimately compile down to assembly language anyway, isn't assembly language by definition the fastest language? And since C is so powerful and compiles so directly to assembly, isn't it going to be the second fastest? This would be a short video, it'll be 3 minutes, and then off to watch me some Amanda McCants reruns. Done and done. But the problem is, in part, the way the question is stated. It's wrong because high-level languages don't actually compile down to assembly language. They compile down to binary machine code. While it is true that you could theoretically write assembly that would also compile to that same machine code, assembly language is a language to be used by humans to write machine code. The fact that there is a direct translation to and from machine code does not mean that the assembly language can therefore somehow take credit for the victories of other languages. Just because you can translate losslessly between two languages does not mean that Shakespeare was originally written in Klingon. Yes, reference of the day. Let's say for a moment that Zig becomes the ultimate winner. Zig compiles to X86 machine code, not assembly language. For assembly language to take credit for such a win, or even a tie with Zig, you would need to disassemble the Zig and convert it into assembly language, such that you then had an assembly source file that you could check into the assembly branch of the project. And that means three things. It means that this supposed fastest assembly language version is dependent on a Zig compiler as an intermediate tool, and it means that an extra step of converting back to assembly language has been made, and it means that a human was never directly involved in the creation of the assembly language version anyway because they actually wrote it in Zig. Some have made the similarly absolutist claim of, well, then machine language is the fastest. Mic drop. And perhaps it is, but to actually earn a title to that claim, a programmer would have to use it as a language to express the algorithm natively in that language. Expressing it in another language and then translating it to machine code isn't the same as using machine code to express the algorithm. If you can even consider machine code a language, which I don't readily grant. If you can write a sieve in hex that is faster than all the compiled versions, then you would win the argument, and I would be, in fact, mighty impressed. Another quick thing I wanted to note is that I grew up in Saskatchewan, way back before the introduction of US cable TV, which meant we were isolated in a way that during my formative years, the region even had its own unique pronunciations for things, such as the Toyota Celica, the Kia Sportage, Nike shoes, and so on. And that means maybe I say SQL and you say SQL, or the other way around. And if so, I apologize in advance. But perhaps instead of cringing every time I do it, just remember, I'm just a wacky Canadian immigrant who's only talking about stuff that I only read in books anyway. At least I don't do these videos in my original accent. One other issue that has come up a few times is people get butthurt over the title because I didn't cover all 45 languages in the first episode. It would have either been a really hours-long episode, or each language review would have had to be shortened down to being a picture of me holding the printout. And hey, it's a series, and it has a series indicator and an episode number right in the title, so yeah. They don't tell you who shot JR in episode 1. And as we get further and deeper into the rounds, however, I do hope to spend more time on the actual languages and less time yakking. If you want the immediate spoilers, I have made the results available in the GitHub repo, but I don't even know the final results because the winner won't be chosen until all the language reviews are completed and everybody's had a chance to improve their favorite language implementation. And speaking of the rules and picking a winner, it turns out that we have a couple of different categories in which I will announce winners, but the overall champion will be determined when I'm done covering the languages individually. At that point, I will then review the then current leaderboard and select the highest performing single-threaded implementation that meets the following criteria. The algorithm must be faithful to the one used in the original C, C#, Python episode. And it must return its results as a packed bit array that uses at most 1 bit per non-negative integer up to the limit of the size of the sieve itself. And by that I mean if the size limit of the sieve is 1 million, it may return at most 1 million bits. And 500,000 is okay too if you're ignoring evens. I significantly prefer solutions that operate on 1 bit at a time in memory as well, but I appreciate that may not be possible in all languages, so have not made that a strict requirement. But if you randomly waste memory wantonly, I do reserve the right to mock it mercilessly. The algorithm can't encode any pre-existing knowledge of primes other than ignoring even numbers. Storing 3 or 5 or 7 or any factor we'll derive from them will be considered unfaithful. It's sometimes cool and can be very fast, but unfaithful nonetheless. The sieve must be completely torn down and recreated for each pass. It cannot cache any info or state from one run to the next or reuse any of its allocations. And finally, the sieve must accept the sieve size as a runtime parameter, as if you were writing a prime number API of some sort. It cannot be baked in as a fixed compile time constant. That's the basics. In some cases, we will only have unfaithful implementations for certain languages. Ideally, somebody will jump into the GitHub for that language and fix it up in time for the final showdown to make it eligible, but if not, I'll still feature the language, but with an asterisk next to its score to indicate it as non-official, sort of an exhibition-style run. We'll get to check out the code in that language no matter what, though. With all that out of the way, it's finally time to dive into some code, starting today with PHP. PHP was created back in 1994 by Rasmus Ledorf, and the raison d'etre for PHP is to run on web server backends. In fact, PHP originally stood for Personal Homepage, though now it somehow means Hypertext Preprocessor. Rasmus has said that he did not plan to invent a programming language. In fact, he's gone so far as to say, there was never any intent to write a programming language. I have absolutely no idea how to write a programming language. When you see the first versions of PHP syntax, you might agree with them, but they really did improve with each version. Let's imagine you had a web page on your personal website and you wanted to say good morning in the AM and good afternoon, and so on. In a web server running PHP on the back end, the web page content is loaded from disk, and then the server scans for the PHP and coded it into the HTML content. When it finds it, it executes that code, which can range from making subtle customizations to the page, such as adding good morning text, all the way up to completely generating the entire rest of the page from a database programmatically. For many years, the vast majority of back-end text processing on pages was done by PHP, and today they still say that about 250 million websites use it, which would be about 75% of the active web servers. Although managed by a web server and operating within a web page is where you would normally find PHP, you can also use it for processing and storing form data that a user enters into an HTML form, for storing data within and manipulating web cookies, or for filtering and restricting access to certain pages on your website. One could also use it for standard server scripting as well. You can execute PHP code directly from the command line with the -R switch. That is how our prime sieve application will function. Let's drop into the PHP code and have a first-hand look. Right away we can see that PHP allows you to define classes, not unlike C++, and that you can mark certain things as public or private access. The declaration of the results dictionary is simple and elegant, and it's even marked properly static, which I always like to see. The constructor right below it is a little less intuitive. The constructor for a class is implemented by defining the __ construct function, and this is where you perform any necessary instance initialization and setup. Next, we are met with two main bit array functions, getBit and clearBit. This implementation likely runs at half the speed it could because it contains an extra unnecessary step. Each time, it's checking to make sure the array index is never an even number. That's fine, but it's not really required because the sieve should never be attempting to do so in the first place unless it had a bug of some sort. So it's better to place that test in an assert or other debug message so that you catch any such scenarios without slowing the program down during benchmarking. Happily, the run sieve function is equally clear. We start with a factor 3 and prepare to run the loop out to the square root of the sieve size. The use of the $sign on every variable is a little weird and ornate for my taste, but I'll assume they had their reasons originally. Otherwise, the logic here is clearly apparent, and the code implements a sieve that is easy to read and clearly follows the same algorithm as the other languages we've inspected so far. Computing the raw bit count is done in an interesting fashion. It's done by summing the entire array of yes/no bits as though they were actually integers. Since each array slot that was left as set would contain a single 1 bit, adding them up as integers has the effect of giving you the total count of how many primes were left set in the bit array. The getTimeDiff function seems straightforward enough. It works in microseconds and returns the time delta in milliseconds. The validate results function is a bit more interesting. The !int means that this is a nullable type. That means the value it returns could be an integer, but it can also be null. And null is not the same as 0. It literally means no value whatsoever. If there is an entry in the historical table, it returns that int value. Otherwise, it returns the null. This is used by the printf function above to display an indication of whether the results are valid or not. And apparently, comparing a nullable int to an int constant is allowed, as that's what this seems to be doing. It's also worth noting that clearly, PHP supports good old C-style printf formatting. It appears both the echo command and the printf command do not provide a carriage return, so it's up to you to do so at the end of your output line if you want to have one. Now, I think the problem with this PHP sample is that it's a little too nice. Seeing it might give you the idea that an HTML page marked up with PHP for server-side processing has always been elegant and readable. In my humble estimation, that's not always been the case, or at least it certainly wasn't always true for PHP in the early days. Let's take a look at a small sample of early inline PHP code from Wikipedia. As you can see, the code in question is actually embedded within the HTML comments, which was pretty much the only way that was practical at the time. Code such as is less num entries 1 doesn't read quite as clearly as perhaps we would like, but the syntax of PHP would improve across the years. PHP 3 was the first version that really resembled what we know as PHP today. For PHP 4, it adopted the Zend execution engine. PHP 5 introduced the second version of that engine, and it was succeeded by PHP 7. So whatever happened to PHP 6 in between? Well, over the years, there have been a number of abortive attempts to integrate UTF-8 and Unicode support, and I think PHP 6 was but one of those failures. And as one of the guys who rewrote the entire Windows shell to make it Unicode, I appreciate what a challenge compatibility with that kind of thing can be. About 2/3 of all PHP installations are updated to PHP 7 today, and all but a scant few percent of the other third are running PHP 5. By the way, if you've never used the live interpreters at W3 schools, they are a handy scratch pad on which you can write your experimental PHP code. So if you're playing with it, stop by there to try it out. If you have PHP installed on your machine, you can execute PHP source files from the command line, and if you wish, you can execute code directly as follows. Note the use of the -r command line switch to tell PHP to run the code directly rather than looking for script begin and end tags within the file. From PHP, we now turn our attention to Perl. I thought the best way to segue from one language to the next would be to summarize the differences between the two languages, and so I turned back to Wikipedia, where I learned that while PHP is a basic, intelligent, object-oriented, utilitarian, and procedural programming language, Perl is a basic, intelligent, object-oriented, procedural, useful, multi-paradigm, and event-driven dialect. And stuff like that is why folks like you and me get our information from videos like this instead sometimes. Let's look at the actual code, where the similarities and differences will be a little more apparent. Perl is more commonly used for actually writing shell scripts than PHP has ever been, and so the first thing you'll see at the top of this file is a tag that helps tell shells like bash that this is in fact a shell script written in Perl. Rather than a class, in Perl you define a package. Everything is dynamically typed, not unlike a language such as JavaScript. The syntax for declaring an associative array or dictionary can be seen where the code initializes mydict with the historical results data. It would appear that the constructor paradigm is implemented in the form of a member function called new. But before an object can work properly in Perl, you'll see an odd-looking statement known as the bless command. It serves to associate an object with its class, so when you create an object it's still generic, but when you want it to become an instance of a particular class and cause the constructor to run, you bless it with a class type, or class name. In this case, it is instantiating those two pieces of instance data, the sieve size and the bit array, and turning that into an instance of the prime sieve class. In the run sieve function, we see variables with $signs again, just like PHP. One perhaps odd and unique feature of the language is that it always tries to give you more than one way to do everything. Simply having an if function or even an if not function just wasn't enough. They chose to add an unless statement as well. If the Boolean expression evaluates to false, then the block of code will be executed. Thus, if you were to say unless x is less than 20 and hit it with 30, then the code would execute. You can use the unless keyword as a conditional for a block, as we see in this case, or by appending it after an arbitrary statement, and we'll see use of that later. In the for loop, there can be found the use of the last keyword, which I would say is effectively a break statement. Because at first I thought perhaps you could say that this pass was your last at any time and the remainder of the loop pass would complete, but it doesn't. No more statements are executed and control drops out of the loop immediately, so it's really a break statement, but you know. The language was designed by fast-talking rebels who play by nobody's rules but their own, so last it is. We see frequent use of the self pointer and the arrow operator, which are very similar to what you've come to expect in languages like C. If you've seen a this pointer, you know what a self pointer pretty much is. We also see the my keyword used a lot, and it's like the var keyword in some languages in that it indicates that a variable being declared is local in scope to that block and inward. In print results, we can see a good example of the somewhat odd syntax for declaring function parameters. The arguments are represented by the @_ operator and assigned to local variables with the name specified in the parentheses. The this pointer is listed as the first argument and is passed implicitly. One of the sketchy parts of these untyped languages is, of course, that you can pass anything in any order and it would still compile and run, but then do fun things when you pass an array where a string is supposed to be. Count primes reads quite clearly, with the possible exception of another use of the unless keyword, which somehow doesn't really fit with the way I think. I'm fairly sure I would personally stick with if when using the language, just because of me, but to each their own. Note how the unless keyword can be applied after a statement, such that the count will only be incremented when the bit is not set. Down in the program main, we have a nice example of the use of a high-resolution timer available to Perl programmers. It's rather elegant in that you simply subtract one time from another, and the difference is automatically provided in floating point seconds. Well, that's about all the Perl we've got time for today, if we're still going to erase them. So let's head on over to the virtual drag strip and run PHP and Perl head-to-head. Prime sieves to 1 million, as many times per second as possible. Well, those sound effects might be a little optimistic for the Perl case. Its score of 64 places it squarely in the bottom fifth of our leaderboard. While the PHP version is 3 to 4 times faster than that, it's only a few slots ahead on the leaderboard. By the way, both are faithful implementations of the algorithm. And I want to reiterate that when a language comes in with a low score like that, it's not necessarily a slight of the language if you don't use it in a performance-sensitive manner. If the language does what you need it to do, and you're not waiting around for it to do its part, That's all that ultimately matters. And besides, if you can get all the primes up to 1,000,000 in like under 100th of a second, how can you call that slow? But it will definitely look that way in a relative terms when we break out the C and Rust and other languages that are ripping off thousands or even tens of thousands of passes per second, and we'll see how those algorithms are implemented as well. Going forward, I'd like to get 3 to 4 languages into an episode if possible, and if you have suggestions on how to match those languages up, please share those in the comments, which I do read fairly diligently. Some groupings like the functional languages are obvious, but when it comes to oddities like PostScript and SQL, where do you pair them? Please take a look at the list of all 45 and share your thoughts. And speaking of sharing, I might as well ask a favor as well. This kind of topic, racing computer languages, is a very narrow niche. So if you know somebody who might be interested in it, or you participate in an online community where it would be specifically relevant, please do share it. Post a link to Round 1 on Facebook, Reddit, wherever you think folks would be interested in it, but do make sure it's an on-topic value add for wherever you do decide to share it. The goal is to reach more people who would be interested in it without spamming anybody who wouldn't. And please be sure to make sure that you are subscribed to the channel and turn on the bell icon so you don't miss future episodes, including the grand finale, where the overall winner is revealed. I'll also be announcing winners in various categories of languages as well, like functional, scripting, and so on, which is why I want your suggestions on how to group them. Thanks for joining me out here in the shop today. In the meantime and in between time, I hope to see you next time, right here in Dave's Garage. This little chair will be waiting for one of you, and a rocking chair for another who likes to rock, and a big armchair for 2 to curl up in. All next time on Dave's Garage.